Good afternoon, and thank you for having me here today to talk about some of the work that we've been busy with in SIMEC mining in Whyalla, in particular our exploration program and some of the results from the drilling that we completed as part of our Accelerated Discovery Initiative. Firstly, I'd like to acknowledge the traditional owners of the land on which we meet today and pay our respects to elders past and present, and in particular the Bangla people whose land upon which SIMEC mining operates in South Australia. The artwork there is from Bangla woman Linda Dare, depicting the Seven Sisters Dreamtime story in the Middleback Ranges. That's just a normal disclaimer and forward-looking statements. So mining in the Middleback Ranges and the birthplace of Australian iron ore industry. So there's been some continuous mining of iron ore for over 120 years. We have an integrated mining, primary steel operations and port. We produce direct shipping ore and magnetite concentrate and blast furnace pellets, producing about 7 to 9 million tonnes per annum from about 3 mine sites. We've got a global DSO sort of remaining resource base of about 100 million tonnes, but as the hematite life of mine, is depleted over the next several years, the company will be transitioning to further developing magnetite resources, and this will play a major part in the South Australian magnetite strategy and provide long-term economic growth and sustainability for Whyalla and the state, and underpins the company's green steel vision. The Middleback Ranges occur in the southeastern part of the Gawler Craton within the Hutchison Group. We've got 3 mining centres at the southern Middleback Ranges, so Iron Magnet there in the south, Iron Barron in the centre there, and Iron Knob in the north. These are all serviced by a rail or tramway that delivers crushed and screened hematite to the port. We've got beneficiation plants to upgrade hematite product to DSO, which are present at Iron Barron and Iron Knob. And the magnetite that is currently mined and concentrated at SMR is pumped by a slurry pipeline to the port and the pellet plant for use at the steelworks and the production of pellets to feed the blast furnace. The Middleback Ranges extend for some 60 kilometres from south to north with a discontinuous cumulative strike length of about 50 kilometres. They are folded by at least 2 deformation events, characterised by north-south striking upright asymmetric folds with gentle north-south plunges. Basement to the Middleback Ranges is the Kooyadoo granite, and unconformably overlying this is the Katunga dolomite, which is predominantly a bedded dolomite anchorite carbonate unit with bands of metapelite, calc silicate and marble. The Middleback iron formation sits conformally over this dolomite, and it contains 4 main distinct facies. The first and the lowest being the sulphide facies iron formation, which locally we call the basal sequence. This unit contains cherty quartzites interbedded with centimetre to decimetre scale massive sulphides with pyrrhotite and pyrite and classic magnetite quartz banded iron formation. The basal sequence transitions into the Duke member, which is a mixed carbonate oxide facies iron formation. Both the basal sequence and the Duke member are the host to the high-grade DSO and magnetite deposits in the Middleback Ranges that are currently mined today. Variations in the styles of high-grade mineralisation are typically a result of supergene weathering and enrichment. The Duchess member, which is the orange unit, is the thickest unit within the Middleback Ranges and is an oxide facies iron formation, principally composed of magnetite and quartzose chert. The oxide iron formation then transitions to a silicate facies iron formation, the Knight member, where the dominant iron-bearing minerals are iron silicates, cummingtonite and grunerite. Overlying the Middleback iron formation is the Cook Gap schist that's been dated at about 2.5 billion years old, and between the Cook Gap schist and the Kooyadoo granite, the Middleback Ranges were formed within a 600 million year window within the late Archean of South Australia. So the magnetite potential of the Middleback Ranges. So historically, only the magnetite carbonate mineralisation was thought to be economic, and this is due to its low quartz content or low silica concentrations. Recently, reverse flotation test work has demonstrated that magnetite silica iron formation, what we call MTS, could be processed to achieve a high-grade 68% Fe product, which is suitable for direct reduction iron feed. This mineralisation that was previously considered waste is now our ore, which unlocks the 50 kilometres of strike length within the Middleback Ranges, of which only 10 kilometres we've systematically drilled so far. We've defined magnetite resources at Iron Magnet, which we also call Duchess South, and Chieftain West. Our exploration program is well supported internally and externally through the, the Accelerated Discovery Program, which is driving our resource growth. So we were successful in the round 3 of the Accelerated Discovery Initiative. We applied for about $270,000 of funding, and that was targeting stratigraphic drilling, Aboriginal employment and training, research collaboration. We proposed to do about 2,000 metres of RC and diamond drilling at Chieftain West and Katunga Hills, and that was mainly to, understand the geometry and thickness, the stratigraphy of the Middleback Iron Formation. We wanted to utilise Indigenous owned and operated Walga Civil to complete our earthworks and to provide a field assistant to the exploration team. We also wanted to use the facilities at Tonsley, and in particular the high logger, to scan the core, and potentially also support a Masters or Honours project, which we weren't able to do, unfortunately. So what did we achieve? Well, we drilled about a 900 metre diamond hole and about 2,500 metres of RC. Now the diamond hole that we drilled is pretty exciting for us. As far as we know, it's the only hole drilled in the Middleback Ranges that intersects the full sequence of stratigraphy from the Cook Gap schist all the way to the Kooyudu granite. And it confirmed that we had over 500 metres thickness of magnetite-bearing iron formation, which significantly upgraded the prospect's exploration target by 30 to 40%. We utilised Walga Civil to complete our earthworks and pad prep, and the field technician from that program has since gone on to pursue a career as an apprentice heavy diesel mechanic at Iron Knob. We resolved the style of folding and geometry to be expected through the use of acoustic televiewer logging and structural measurements of drill core. And the 900 metre diamond hole was scanned with the high logger and is now included in the National Virtual Core Library and stored at Tonsley, which is the only hole from the Middleback Ranges to be included to date. The two figures here, so on the left we've got some high logger data. The top is the shortwave infrared logging and the bottom is the visible near infrared logging. And on the right, we've just got some downhole histograms of major elements against our log geology. And overall, we had a really good correlation between the high logger data, our assays, and logging. As we learn more about the deposit and collect further detailed data, we're starting to implement machine learning into our geological and geometallurgical domaining. So converting the potential. So prior to the ADI drilling, we drilled about 76 holes for about 25,000 metres. Post-drilling CW129RD, we've drilled a further 200 holes for about 72,000 metres. And next calendar year, we've got plans for about another 34,000 metres. And these are targeting, the western limb and strike extensions to the north and south. All of this work to date has enabled us to complete a maiden inferred resource for the Iron Chieftain West deposit of about 870 million tonnes at 36% mass recovery. This resource is largely constrained by the depth limit of our RC rigs. We've had to drill some 500 metre RC holes, which isn't something that's commonly done. And the work that we're undertaking this year is to drill deep 600 to 1100 metre diamond holes to convert our exploration target of 1.3 to 4.5 billion tonnes into resource. This deposit remains open at depth, along strike and down plunge to the south. Outside of Chieftain West, over the past 6 years, we've been pretty busy defining and understanding the potential for large-scale magnetite mineralisation in the Middleback Ranges, building on our operational knowledge gained from mining the iron magnet deposit and further test work on other styles of magnetite mineralisation. The past 7 years has resulted in a 10-fold increase in magnetite resources from about 150 million tonnes to 1.54 billion tonnes at about 34.34% mass recovery through DTR. Beyond Chieftain West and the southern Middleback Ranges, we have a really healthy pipeline of targets in the northern Middleback Ranges and proximal to Iron Knob, with a cumulative exploration target of 3.7 to 8.3 billion tonnes. We've got a lot of work to do. So our magnetite exploration pipeline is a generational magnetite opportunity. With high-resolution geophysical data to inform our targeting, we can leverage our existing assets, infrastructure, and intellectual property. With a large-scale resource already defined at Iron Duchess and Chieftain West and a very healthy exploration target, we look to secure the long-term future for mining and magnetite production in the local region and support the company's green steel vision. And finally, we wouldn't have got here without all of our partners that have supported and continue to support our work programs. Thank you.